Hi, it's time for another math easy. So we're going to discuss just some random topic here. Actually, there's odds that my friend Dmitry will score 4 goals in the final of Urban Rec, or just yeah, around 4 goals in the final of Urban Rec Soccer, which is just a co-ed recreational league, and it's 7 versus 7, one goalie, so six versus six, and yeah, it's a co-ed league, so you need at least 2 girls on at all times. And I've played this for a couple years, and last spring we actually won the championship, and now we're in the final this Thursday here. So we got the final coming up, and basically my friend, he's this really streaky player. So my friend Dmitry, I'll show you the Excel sheet I made soon, but just want to get something down before. So he's really streaky, and he wanted to know basically what his odds of scoring a lot of goals in the final are. Okay, so he's really streaky. Now let's look at the Excel sheet. So here's the Excel sheet that I made, and basically what I did was I first I tabulated all the goals he scored, because I compared from last spring and then this spring, and now it's a summer season. So we have 12 games. The last 3 are playoffs, and so right now as the goals breakdown, so if you have games 1, 2, 3, 4, I tabulate all the goals he scored. So he had 2, 3, 3, then 0, then 3, 2, 1, etc. So he had a lot of goals in the first season. He had 26 total. So now this is the final that is coming up this Thursday, and he wants to see what the probability is. So basically I tabulated this one as well. So as you can see, he had already 3 4-goal games inside between the 2 seasons. So there's 24 games total that there's to be played. We've played 23 already. There's 12 per season. So he had 26 the first season, 16 this season. If he scores 4, it'll be 20. But yeah, he scored a lot more in first season. But regardless, the average goals per game he had was this. So what I did was look at standard deviation here. And I'll show you what this is in more in depth in another video. But if I just want to quickly break down how the standard deviation probability model is. So I just assumed it would follow it. So if you have something like this, and this would be, let's say, goals, and this is the average here. So this is average. Usually it's mu, or that's usually what's given, and the y-axis is just probability here. And what this is in this case here, one standard deviation, which is usually given as sigma. This is standard deviation. Is basically it's just a number that such that if you have plus the average minus standard deviation from the average and plus it, so if this is plus, this is a minus, then this whole probability of having let's say goals fall between the average and one standard deviation plus and minus of it, this is 68%, 68.2% probability, or basically the average of how many times it would actually happen. So if we go back to this one, here's basically a standard deviation model. So 34.1 plus 34.1 is 68.2. Basically, then if you keep going more standard deviations, you're going to get 13.6%. These are cumulative, just to recall. It's cumulative percentage. So this is a percentage inside this, and basically going above to 2 standard deviations here. Between these is 2.1%, and so on. And this average, yeah, this is just average. So now if we go back to the model here, so we calculate the standard deviations, what I did here, so I assumed this model would work. It's usually works for random scattered numbers like this, or like if your classroom grades or whatnot, so it's usually a good model for that. So now if we look at the total goals here, just plot a probability table here. This one is just a straight calculation, but just to get an idea. So he had a lot more goals in the spring, and then the summer the average is a bit less, but the standard deviation is more, because what this says is that although his average was less, he had actually more 4-goal games, so that there's a higher percent chance of actually getting, well, just jumping from the average. So he has a higher percent chance of scoring more goals compared to the average than he had in the first season, even though his average is a lot more. So he's more consistent in the spring, less consistent in the summer, but is a good chance of getting more goals still. And then if you look at just average minus standard deviation, call this A, the probability of scoring more than this function, this was just average minus this, and then this would fall between here. So then all I did in this calculation was 100% minus this percent here, which is basically 50. This is greater than, right? So then I minus 50%, and then subtracted by this one, 34.1. So I subtract everything from this one. So this 84.4% is just this one. So I would just 100 subtracted by this, whatever this is. And as you can see in this case, his probability of scoring more than, well, for whatever this is, 84%. So in the spring he had around 9.7, so this is around 1 goal. So 84% chance of scoring more than it. In the spring a lot less. This is basically 84% chance of scoring more than, or 0 goals. And both seasons 0.52. But we're not dealing with, we're dealing with integer in real life, so this is not that telling. And also if you look at this one, if you increase by 1 standard deviation here is around 3 goals. So around 3 goals, around 15% chance of scoring more than that. And then going back to the standard deviation of, this is 4 point. This is around 4 to 5, is about 2%. But also what you could do with Excel, you could just put this equation here, which is actually this equation here, normal distribution equation, which basically gets you the probability of anything less than 4. So I put a 4 normal dist 4, and then you basically put in the mean, which is this one here, standard deviation, which is this, and the cumulative, well, the cumulative probabilities, this is just 1. It's all up to 1%, or 100% is 1. And then subtracted by, so we get 6.2% probability for the first spring that he gets more than 4 goals, and 3.1 for the summer, and an average around 4.8 or 5. But when you look at this, like if you look at this more in depth, how he scores, every time he scores a lot of goals, it's usually because he scored a lot less. So if you look at this one here, the spring is more consistent, but every time he gets a 0 here, he gets 3 goals here. He gets 1 goal here, he gets 4 goals. He gets, except this is the only one that's different. This is 1, and then he gets a 0. I don't know what happened there, but then he followed through with a 4-goal game, and now he has 0 goals. So now what do you think he's going to get here? So basically what I did here, I tabulated all the instances he scores 0, 1 goals last game, and then input the goals that he scores the next game. So if you look at all instances, the first instance is basically occurs here, so he gets 3 goals. Second instance, he gets 1 goal, so 1 goal, and it's keep going on, 3, 4, 2. So then I would do normal distribution of this. And also if you were to graph this chart first, this is a chart of when he scores a lot of goals. So every time he scores a lot of goals, he scored a lot less. This is red is summer. So he scores a lot here, he had 0 here. He scores a lot here, he had only 1 before. So every time he scores a lot is usually, except the spring he was a bit more consistent here. He had 2 straight 3 goals. But then again he gets 0, goes back to 3 goals. So if we go back to goal odds. So now, if we tabulate this one here, get the total average. The average is slightly higher than the spring one, but the standard deviation is much greater than that. And then calculating it based on this equation, we get 11%. So there's an 11% chance, according to these calculations, or great that he'll score more than 4 goals. But yeah, so I would put it down at 11%. Of him scoring more. But in this case, if you look at the playoffs, he usually scores a lot more. Well, in this case, 4 goals. He had, what is this, 8 goals in 3 games. That's a lot more than his average. And also in this case, I would say it's a bit more than 11 because he went a 0 here, a 4, and a 0. So he hasn't scored that much in these 3 games, except this one. So he usually is really streaky. So I would bet on him scoring 4 more goals. Especially because the final and he steps up his game. Well, that's all for you. You can always download these notes here. Hopefully you learned, and this is just a random one here, but if you learned at least about probability and normal distribution, so I just assume that it follows this model. I'll look in depth more into it. But yeah, so well, hopefully he does score 4 goals and we win the final again. We get a second shirt. Well, that's all for today. Hopefully you learned, and stay tuned for another math easy solution.